Hello everyone, welcome to the online lecture of Computer Integrated Manufacturing in Automobile Industry. I am Milan Trivedi, Assistant Professor at LJIET Institute of Engineering and Technology. Today we are going to discuss about the chapter number 2, that is NC machine tool, and that specifically we are shifting towards the part programming. Let us begin with the concept of different codes we are using in the case of part programming. As we see in the earlier class that there is a specific format in order to write the part program. But in order to understand even the part program sentence, we need to first of all get the idea about the G codes and M codes. So let's get started with the G codes. I had listed out the different G codes and the M codes which we are actually specifically using in our problems of GTU. So let's get started. G00 is used for the rapid travel. Rapid travel means whenever you are not doing the cutting operation, tool is resting somewhere at very extreme position and we need to bring to the specific point from which we will start the cutting. So in between that path will be a rapid travel path. In order to bring towards that particular point of cutting area, we need to move tool rapidly, right? So for that we are going to use command G00. Then second is G01. Whenever we want a linear cut, means a tool will be moving only in a single axis. At that time we are going to use G01 command. Whenever tool is required to move in a circular way, we need to have G02 and G03 based on the movement of circulation. Say for example, if tool is moving in a circular clockwise direction, then we are going to use G02 command. And if it is moving in an anti-clockwise direction, then we are going to use G03 command. Then the G28 command. G28 is for the home position of the tool. Every manufacturer, machine manufacturer has set a home position of the tool, right? And at the end of each and every operation, we are sending the tool to its home position, right? For that, we are having this command G28, and along with that, we need to specify address also. That has been given with the help of UVW axis, right? U0, V0, W0 is considered as a home position address of the tool, right? In order to send the tool at U0, V0, W0, we need to mention this G28 command. Then another is the way of writing or giving the dimension. In entire program, we are specifying only the values of the particular numericals, right? Say for example, at point number 20, the tool is required to be reached, right? So we are just writing 20. But how does that controller understand that in which unit the 20 is been mentioned, right? We are having a practice in our engineering graphics also that at the end of each and every diagram we are writing this line that all dimensions are in mm. So in same way to the controller we need to specify that in which unit we are giving the dimensions, right? For that we are having a specific G code. If you are mentioning the dimensions in the each, then you need to mention G70, and if we are giving the dimensions in a metric mode, then we need to write G71. And in our Indian industrial standards, in most of the industry, we are following only the metric mode. So we are also following that practice in our programming also. We are going to write G71 at the start of each and every program. Now let us understand other G codes. Next G code is G74. G74 is a multiple stock removal code. Normally, when we need to cut a 50 mm diameter shaft into 40 mm diameter shaft, then at that time for each and every cut we need to increase depth of cut. Means we cannot directly cut 50 die into 40. We need to have 1 mm depth of cut. So what will happen is 50 mm diameter will reduce to 48. Then we will again write a program for cutting 48 into 46. Same way 46 into 44, 44 into 42, but the set of instructions will remain common, right? So the program becomes lengthy because there will be a repetitive set of instructions. So in order to avoid that, we are having this G74 command, which is for multiple stock removal. You will get idea about this when we write a specific program on that. The another one is G78. G78 is for multiple threading cycle, right? Normally when you drill any object in a milling machine, we are going to use this command. The next one is G90 and 91. We are having basically two methods to write a program that we had already understood while the concept of classification of CNC machine, that is absolute and incremental. In most of the cases, we are going to follow the absolute method of programming. So this G90 command will also be a common command at the start of each and every part program. The next one is for the RPM range. Normally spindle is required to be rotated into three specific range zones: low, medium and high. In order to specify range, we need to write G93 command. Right? That will be also a common command. And the last set is for the feed rate. Normally feed rate is given in two units, either in mm per revolution or in mm per minute format, right? In whichever unit the feed rate has been specified in a problem, according to that we need to write this G code. If it is given in a mm per revolution like 0.1 mm per revolution, then you need to write G94 at the start of command. And if in the problem if it is written like that 110 mm per minute, then you need to write G95 at the start of command. Okay. Last is the different M codes. M02 is for program, and at the end of each and every program we need to write this M02 command, because that is showing that the program is completed. At the start of operation we need to start the spindle, right? But again, starting the spindle is having two conditions, in clockwise or counterclockwise. If you want to start the spindle clockwise direction, then mention M03 at the start, and if you want to start the spindle in anti-clockwise direction, mention M04, right? And at the end, after cutting operation, we need to have the spindle cut off, right? So for that you just need to mention M05. The next one is for the tool chain, right? As we seen earlier that in most of the CNC machine we are having a cassette or a turret which is actually holding different tools. Which specific tool you need to use for the cutting operation, that is required to be mentioned with the help of this M06 command. For that, if you write M06 T01, then the tool number 1 will be taken for the cutting operation. If you mention M06 T02, then the second tool will come into picture, right? Then the next set is for the coolant, right? Whenever we are doing cutting operation, normally we need to sprinkle coolant, right? In order to avoid the heat generation. Because if heat generation is at a very specific point, then it can lead to development of heat affected zone, and it can have a huge impact on the material as well as the tool. So in order to start the coolant, we are having again two conditions. Coolant can be in the flood type format, in which large volume of coolant will be supplied, or it can be in the form of mist, where spray kind of pattern will be generated. So for that we are having this M07 and M08 command. The another M codes are M09, which is used to cut off the coolant. M30 is showing the end of tape, means after program end we need to mention that again the tape has been completed. Then M40, 41, 42 is indicating the speed range. Right. G93 command we had seen, that is for specifying the spindle speed range, right? Once you write that G93, along with that you need to mention this either M40, 41, 42 according to the application, right? If you want to operate in a low speed range, write M40. If in the medium, then M41, and in high speed, M42. Now let us understand the axis designation in the lathe machine. Normally, we are having this axis designation with the help of right and thumb rule that we had already understand in our last lecture, right? With the help of right and thumb rule, we can indicate the different axes, right? Once you know about the particular one axis, right, then with reference to that you can find the location of another. So what we are normally doing practices, let us have this three different axes. We can show any axis on any of the line. Let us take that thumb is indicating z axis. We need to point thumb towards the spindle direction. This is the golden rule that the spindle axis will always be a z axis. So if you point thumb towards the spindle direction, then we will get the direction of x and y, right? Y will be the vertical movement, x will be the horizontal movement, that is along the depth of cut. And if you are giving the feed, that will be indicated by the thumb. So that is shown over here that the feed direction is z axis and depth of cut direction is a x axis. Now let us see how to set the 0 points. In order to set the 0 points, what we actually require to do first is we need to fix the workpiece into the spindle. Then physically we will touch the tool towards the surface, right? Then we will set that point as a x0 point. Then we will physically touch the tool towards this surface, right? Face of the object. Then we will set mention in that this surface is z0 surface. So what does the tool understand is that meeting surface of z and x will be taken as a 0 point, right? That is the x0 and z0 point. Naturally that will happen. This surface, that is x0 line, and if vertical surface, that is z0 line. So this particular point will be acting as a x0 z0 point. So if we draw the axis, then from x0 z0 left segment, that will be a minus z, this is a plus z direction. Same way, upward direction, that will be a plus x, downward towards operator, that will be a minus x direction. So for each and every new object, we need to every time we need to set this x0 z0 point physically on the machine, right? Once we set the 0 point, we can do the programming. That's all for today's lecture. Thanks for watching.